Good evening, friends. In today's lecture, we will be discussing about how to solve a circuit using nodal analysis. So this is a basic circuit that I have drawn and you can see it on your screen. Our objective for today is to solve the circuit using nodal analysis. So before solving any circuit, there are certain prerequisites. In order to make yourself capable of solving this circuit, you must know how to solve these two circuits. So these two are very basic circuits and they serve as a prerequisite to solve any questions related to nodal analysis. So this is question 1 and this is question 2. So let us move ahead. So nodal analysis. So what do you mean by this word called as nodal? Nodal means it is a connection between two branches. It is the connection between two or more branches. So we already know what a branch is. A branch is a path that contains an element or that carries an element, and the elements could be sources or they could be any passive elements comprising of R, L and C. So if you have two branches of these manner, then this is called as a node. If you have two or more branches, then this is called as a node. Now there again, there is a basic difference between two words. One is node that we are already discussing over here. There is another word called as junction. Now the meaning of this word junction is the connection between three or more number of branches. Say for example, here you have got three branches in this fashion. Let us have four branches. Then this thing is called as a junction. Now this is again also called as a junction. But now look over here. A node means it is a connection between two or more number of branches. A junction means it is a connection between three or more number of branches. So anything that is called as a junction is also called as a node. So from henceforward, whenever you come across this term called as a junction, then please be sure that that junction is also a node, because a node is a connection between two or more number of branches. So this is a basic discussion about what is a node. What is the purpose of using this concept of nodal analysis? Nodal analysis uses the concept of KCl. That is the Kirchhoff's current law. So if it is using Kirchhoff's current law, then naturally it is based on conservation of charge. Often in circuits where you are required to find out the nodal voltages, the voltages at these nodes, whenever you are required to find out the voltages at the nodes, then this nodal analysis becomes handy. Using this nodal analysis, it becomes very easy to find out the voltages at the specific nodes. So this is the purpose of using nodal analysis. So what is the basic step? The node across which the voltage is to be figured out, first that node is to be identified. Once that node has been identified, please assign a particular name to that particular node. So that name could be either VA, VB or V1, V2 and so on. So once this identification of the nodes is done and the assignment of the names, particular names to that particular node is being done, apply KCL at that node. So what do you mean by KCL? KCL says that the summation of current at any point, the summation of current at any point is equal to 0. So what does that mean? It means the sum of the currents entering a particular point is equal to the sum of the currents leaving that particular point. So I am writing it over here. Summation of the current entering is equal to summation of the current leaving. So if you want to apply KCL at a particular node, it clearly means that this particular condition is to be satisfied. Now how to write these KCL equations? So use Ohm's law at those nodes to express the branch currents in terms of nodal voltages. Now whenever you will be writing KCL, you will have only two ways of writing this KCl equation. Either you know the value of I that is flowing through that node, or you have to express that current in the terms of V upon R. These are the only two ways in which the KCl equation can be written. There is no other way to it. Either you know what is the value of the current that is flowing through that node, or you have to express that particular branch current in terms of the nodal voltages, and you have to write it in a manner V by R. So these are the basic steps that one should know before writing the nodal equations. Now let us go into the solving few numericals, and finally we'll solve the numerical that was being shown in our first slide. So this is our first question. But over here, while working with the nodal analysis, we do not have to bring the picture of the loops or mesh into consideration. We'll just talk in terms of nodes. A node is a point which connects two branches or more number of branches, two or more number of branches. So according to the definition of node, this is a node, this is a node, and this is also a node. But in the question we have been asked, find V1. So specifically we have been asked to find out the voltage at this particular node. Now while solving this type of questions, we can have two sets of approaches. One set is, you can consider this to be the only node in the entire circuit and carry out the analysis, or you can represent this as a node, this thing as a node, and this thing as a node. That means you will have three nodes in your circuit, and finally you have to solve the given circuit. So I'll be solving this circuit using both the approaches. So let us go with the first approach. I'll be considering right now only V1 as a node, and I'll start solving the circuit using nodal analysis. So as I've stated earlier, for nodal analysis one has to write the KCl. KCl means you have to either write the equation in terms of I or in terms of V upon R. There is no other way to write the KCl. You cannot write the KCl only in terms of V. That is incorrect, because KCl means it is the summation of current entering equal to the summation of current leaving, or it is based on the conservation of charge principle. So there is no concept of just writing or involving the voltage into the equation. If you are working with the voltages, then definitely there has to be a respective resistance for which you have to write the current equation. So is this part clear? You should either write the equation in terms of I or in terms of V upon R. Now, if I am considering only one voltage, that is V1, yes, there is a basic assumption. Prior to writing the KCl equation, there is a basic assumption that we have to follow. The current flowing from any node is considered to be in outward direction. The current flowing from any node is considered to be in outward direction. Say for example, if we are considering right now only one node, that is V1, then the current that will be flowing from this node is assumed to be flowing in the outward direction only. No currents are allowed to flow in the inward direction. This is a basic assumption that I follow. Is this part clear? Now I have to write the KCl equation. Now as we know, our assumption is the current should be flowing in the outward direction from any node that we consider. So we have only one node over here, that is V1. So the current will be flowing in the outward direction only. How many branches are connected to this node V1? This is very, very important. How many branches are connected to this node V1? There are 3 branches connected to this node V1. So since there are 3 branches connected to this node V1, the KCl equation that will be written from V1 should have 3 terms. This is very important. The number of branches connected to a particular node should be equal to the number of terms that would appear in the KCl equation. In case you are not able to write the KCl equation for any particular branch connected to that particular node, then in that case KCl cannot be applied. I'm repeating this part once again. You should first figure out what is the number of branches that is being connected to a particular node. If the number of branches connected is 3, then you should get 3 terms in your KCl equation. In case you are not able to write the KCl equation for any particular branch, that means the KCl equation cannot be written for that particular node. So this is the underlying principle or the underlying fundamental concept behind this nodal analysis. Now over here for this node V1, we have got 3 branches connected to it. One that is going in the left hand side, one that is going in the downward direction, and one that is going in the right hand direction. So let us now begin with the left hand side. Now let us write the equation for the left hand side branch. The current will flow in the outward manner from V1. So if you are considering the left side branch, the direction of the current will be something like this. It will start from V1 and it will try to take a left turn, and then it will come down and it will try to reach the ground. This represents the ground potential or the zero potential. So how do I write the KCl equation for the left hand side branch? Now this is V1. V1 is a voltage term. Now it goes in the left hand direction. Do you encounter any other voltage sources present along this path? Yes, there is one. That is the 45 volt source. So when you are coming from, or you are traveling from V1 and traveling towards the ground, you encounter this 45 volts. Now upon encountering, what is the last sign of the voltage source that you encounter? You are traveling from V1 in the downward direction. So what is the last sign that you encounter? It is minus. So what will be your first KCl equation? V1 minus 45. Are there any other voltage sources after 45? Yes, we are finally reaching the ground potential. So that is at 0. Minus 0. Now there are no more voltage sources. Are there any resistances associated with it? Yes. So it will be in the form of V upon R in order to represent the branch current. So it will become V1 minus 45 minus 0 upon 2. In case there is no resistance present, you cannot write the voltage equation in this fashion. Because if there is no resistance present, it clearly means the resistance value is 0. So it will make the entire term to be infinite. And that is an incorrect way of representing. So there has to be a presence of a resistance. So we have already written the equation for the first branch. Now let us move on to the second branch. Yes, one more thing. We have considered, or we have assumed, that the current flowing from any node is considered to be in the outward direction. So everyone is moving out in the outward direction. So according to KCl, summation of I at any point is considered to be 0. Since everyone is in the outward direction, so we need to add up all the currents. Had there been some current which is traveling in the opposite direction to that of which we have assumed, then we will consider that as a minus. But over here our assumption says that the current has to flow in the outward direction only. Now for this middle branch, the current will flow in the outward direction. So definitely it will start flowing from top to bottom. Is there any presence of voltage source in this particular branch? There is none. There is only one potential, that is V1, and finally it is coming to the ground potential. So there will be a plus because all the currents are assumed to be going in the outward direction. For the second branch, my equation shall be V1 minus 0 upon 12. So V by R form. So it finally represents the branch current for this particular branch. And this term represents the branch current for this particular branch, starting from here till the end. Now coming on to the last branch. Since the current is flowing in the outward direction, so the current will start moving out from V1. It will traverse along the 9 ohm resistor, pass through 30 volts, and finally it will reach the ground. So of course we are encountering, or we'll come across another voltage source. So while traveling from V1 and while reaching to this 30 volts, what is the last sign that was being encountered? It is a minus. So it will be V1 minus 30 minus 0 upon 9 is the term that represents the branch current for this entire branch. And let me make one thing very clear, that this V by R represents the current, the branch current. So this branch current is for this particular branch starting from V1 and ending at the zero potential. Do not assume that this is the branch current starting from V1 and ending right after 9 ohms. No, since we are considering all the voltages, that is starting from V1 till the zero potential, so this is the branch current for this entire path. So we have 3 branches connected to V1 and we have already obtained 3 terms. That means we have been successfully able to write the KCl equation for that node V1. So what does KCl says? KCl says that the summation of the current at a particular point or a particular node is equal to 0, or summation of the current entering is equal to the summation of current leaving. Since our assumption is in such a fashion that we have assumed that all the current should flow in the outward direction, so we had none that was coming in the opposite direction. So everything was additive in nature. So how do you conclude this equation? That is equal to 0. So this is how you should write the KCl equation. How many unknowns are present in this particular circuit? There is only one unknown and we have obtained one equation. Upon solving this equation, we shall find out the value of V1. So this V1 value would come out to be 37.2 volts. So this is the first set of approach using which we have solved for V1. Let us move on to the second set of approach. I have redrawn the circuit over here once again. As I had told you earlier, since over in this question it has been asked to find out V1, you can consider only one node for analysis. This is V1, or by the definition of node, which means the connection of 2 branches, you can consider 3 nodes at a time and you can solve for all the 3 nodes. So I have already represented these 3 nodes by red dots and I am writing them as VA, VB and VC. And once we solve for VA, VB, VC, what will be the value of V1? Which will be equal to whatever value that we obtain for VB. That is clearly visible to us from our analysis. Now in the nodal analysis, there are certain terms that one needs to know. The terms are something called as a reference node and a non-reference node. This non-reference node part we'll be dealing with in the subsequent classes or in our future classes. Right now we'll only be discussing about this reference node. What do you mean by a reference node? If a voltage source is present between a particular node and the ground potential, then the value of that particular node is same as that of the voltage source. I'm writing it over here. That is, if a voltage source is present between a node and a ground potential. So do we have any reference nodes in this circuit? Yes, we have. We have 2 reference nodes in this circuit. Now look at V1. Now V1 is connected to a voltage source of 45 volts and that is further connected to ground. So is this voltage source present in between a node and a ground potential? Yes. So is it a reference node? Yes. So if this is a reference node, how are we going to take advantage of this reference node? Now whenever you come across a reference node, the value of the given node always becomes equal to the value of the voltage source that is present in between. So what happens according to the definition of reference node? VA becomes equal to 45 volts. And why is it 45? Because look over here. What is the sign that is close to the node? Plus or minus? It is plus. Even if you are coming from the ground, now you are coming from the ground, what is the last sign that you are encountering? It is plus. So VA is given a plus sign. Had this sign been reversed, VA would have been negative. Now look into this another node, that is VC. Is VC a reference node? Yes, because there is a voltage source, that is a 30 volts, which is connected to VC and to ground. So this is again one of the reference nodes. So according to the reference node definition, VC will also be equal to plus 30 volts. Now there is one more important thing. The definition clearly says that for a node to become a reference node, there should be a voltage source present between a node and a ground potential. Now let me redraw the circuit in a different manner. Now I have drawn the same circuit and I am drawing just the part of the circuit. So this is VA, this is 45 volts, this is 2 ohms and this is ground potential. The rest of the circuit remains as it is. Now is VA a reference node? Certainly not. Why? Because this 45 volts is not present in between a node and a ground potential. There is a presence of a resistor in between. So you cannot write here VA equals to 45 volts. This is absolutely incorrect. By the definition of reference node, it means there should be and only the presence of a voltage source in between the node and the ground potential. If this condition is satisfied, then that reference node carries the value of the source that is connected to it, with the sign which is closest to that particular node. Under no other conditions, a node can be called as a reference node. I hope this part is very clear to you. Now based on this reference node concepts, we can write down the equations of the circuits and finally solve for this VB, which will eventually be equal to V1. Let us see how we can write the equations. Now based on this reference node concept, we have already obtained the values of VA and VC. We only have to write the equation for VB. Now, how many branches are connected to VB? There are 3 branches connected. I am showing it with the help of arrows. This is one branch connected, and as per our assumption, the current should always flow in the outward fashion. So, starting from VB, it is going in the downward direction. This is another branch. Now since we already know the value of VA, we shall not consider the entire path for our analysis. We will start from VB and will end at wherever VA is. Similarly, the third branch is starting from VB and ending at VC. So these are the 3 branches that are connected to VB presently, and we have to write our nodal equations or the KCl equations for these 3 branches. 3 branches means there must be 3 terms. Let us see if you are able to write or not. Now let us start writing for the first branch, that is on the left hand side. What will be our equation? It will be VB minus VA. Remember in the previous equation, we used to write the equation up to the ground potential. Over here, we are not going up to the zero potential. We are stopping at VA itself. Why is it so? Because we already know the value of VA. In case the VA value is not known, then we have to write equations for VA in order to know the value of VA. So VB minus VA upon 2. So this is the branch current for this particular branch, joining VB and VA. And what is the direction of the current? It is in the outward direction from VB. Plus, since all the currents are assumed to be in the outward direction. For the middle branch, it is VB minus 0 upon 12 plus VB minus VC upon 9. The same concept over here as that of VA, since we are not writing for this entire path and we are writing the equation only for the branch current connecting VB and VC. So this is our term, VB minus VC upon 9 is equal to 0. The value of VA is known, the value of VC is known. Please substitute those values and finally VB will come out to be 37.2 volts. So these are the 2 sets of analysis that can be used to find out the nodal voltages. Now let us move on to our next question. So this is our second question. Over here it says find out the voltages at these points 1 and 2. We'll use the same concept that we have been using in our previous equations. Let us see if we are able to solve it or not. So now writing down the KCl equations at that point A, or you can say that at node 1. We can name it as node 1. Writing down the KCl equations at node 1. How many branches are connected to this point or node 1? There are 3 branches. This is first, this is second, and this is third branch. So can we write down the equations for these branches? Okay. Before we proceed with writing the KCl equations for these branches, there is one more thing that you need to know. In our previous equations or in our previous circuits, we only had node voltages or we only had voltage sources into the circuits. In these questions, we have current sources. So there is one thing that you need to know when you are dealing with the current sources. What was our basic assumption? Our basic assumption says that the current should always flow in the outward direction, which is true. This is our assumption. However, if a current source is present in a particular branch, then that particular direction of the current source is to be taken into consideration. I am repeating this part again. Our assumption says that the current should always flow in the outward direction for any node that we are considering for analysis. However, for any current source that is present in the circuit, the direction of the current source is to be considered. Is that part clear? So for this node 1, there are 3 branches connected. Now coming to the first branch, that is the left hand side branch. This is the node voltage at 1. Is there any current source connected in this path? Yes. What is the direction of that current source? Is it in the outward direction? No, it is in the inward direction. So how do we write the equation? The KCl equations can be written in only 2 forms. Either the current is known or the voltage can be represented in the V upon R form. Over here, for this particular branch, the first case is valid. The current source is present, so the first term of this KCl can be represented in terms of the current value only. There is no requirement of this V upon R. This V upon R is required if the current is missing or if the current source is not present. Now since the current source is present over here and this current value will definitely travel across this 1 ohm resistance as well. So this value of this 1 amp is to be taken into consideration while writing this KCl equation. So what will be your KCl equation for the first branch? It will be -1. Why -1? Because our assumption says that we should always go in the outward direction. However, for this particular branch, a current source is present and the direction of that current source is in the opposite direction of what we have assumed. So we have to give it a minus sign. Now let us move on to the second branch. The second branch is the middle branch. Now the node voltage at this node 1 can be written as V1. So plus V1 minus 0 upon 2. Over here there are no current sources present. So you have to write the KCl equation in terms of V upon R. And I have considered this voltage at 1 as V1. So V1 minus 0 upon 2. Why V1 minus 0 upon 2? Because assumption is it should always go in the outward direction. Now coming to the final branch, that is connecting V1 to V2. So we can write V1 minus V2 upon 2. So these are 3 branches connected, so we have got 3 terms. That is equal to 0. Many of you might be wondering that when I will be writing the KCl equation at node 2, then I will be assuming the current for this particular branch in the outward direction, and when I wrote the equation at node 1, I assumed the current for this particular branch in the outward direction. So they might be thinking that this would lead to an erroneous result. Absolutely not. This will never lead to erroneous results. Why is it so? Because you are taking one node at a time. When you are writing the equations for node 1, you are assuming all the currents in the outward directions. Now when you are considering the nodal point 2, you are considering all the currents in the outward direction. So naturally, these things are taken care of. Because just like in mesh analysis, we always had a parent loop or a parent mesh. Similarly, for nodal analysis, we have got a parent node. So whenever you are considering the parent node, you have to assume the current in the outward direction. In case if you are making some mistake, like while considering this node voltage 2, you are assuming that the direction of the branch current for this particular path is from left to right, then you are actually bringing a wrong concept into picture. So the underlying principle is, no matter whichever node you are considering, the current should flow in the outward direction. Based on this concept, let us write down the equation at point 2 or at node 2. What will be our equation? How many branches are connected to node 2? There are 3 branches, so definitely you will be having 3 terms. So what will be the first branch? The first branch is from 2 to 1. The second branch is from 2 to ground, and the third branch is along this path. So if I am writing the equation for the first branch, that is connecting node 1 and 2, what will be my equation? V2 minus V1 upon 2 plus, since all the currents are in the outward direction, it is a plus sign, V2 minus 0 upon 1 plus. Now for this third branch, there is a current source present. Since there is a current source present, I have to take the direction of the current source into picture. So is the current source in the same direction as my assumption? No, it is in the opposite direction. So it will carry a minus sign. So minus 2. So 3 branches, we have got 3 terms equal to 0. How many unknowns were being asked in this question? 2 unknowns. We had to find out the voltages at V1 and V2 respectively. So you have got 2 equations. Upon solving these equations, your equations will come out to be these. So once you solve these simultaneous equations, the final values of V1 and V2 are, V1 will come out to be 2 volts and V2 will come out to be 2 volts. So is this part clear? The current source being present in the equation, and you know how to write down the KCl, we can move on to the first question that was being asked in the first slide. So this is our question that was being asked in the first slide. Over here, they are asking us to find out the value of VA, VB and VC. So whatever concepts that we have learned in our initial problems, that will be helpful over here, because whatever problems we have solved, those form the standards. Once you know how to solve those 2 questions, no matter how complex a question is, you will be able to solve everything. So let us see how to solve this type of questions. This question says, there is a node VA which is connected to 1, 2, 3, 4 branches. So VA should have 4 terms for writing the KCl equations. What about VB? VB has 1, 2, 3. So the KCl equation when written at node VB should consist of 3 terms. What about VC? 1, 2, 3, 4. Again, VC will have 4 terms. So I am writing it over here, 4, this will have 3, this will have 4. Before I move on to write these equations, I should check for one thing. Are there any reference nodes present? Yes, I can see the presence of a reference node in this circuit. Where is the presence of this reference node? This is a reference node. This 60 volts is connected to a node VA and it is connected to ground. So VA is a reference node. So according to the definition of the reference node, what is the value of VA? VA comes out to be 60 volts. So once you know the value of VA, do you still require to write down the KCl equation for VA? Not needed. because the value of VA is already known. And once you know the value of a particular node, there is no requirement of writing down the KCl equations at that particular node. So this is the basic thing that you should look for. Prior to writing any KCl equations at any particular node, look for reference nodes. Are there any reference nodes present? Then please assign the value of the voltage source to that particular reference node. Is that part clear? So how many unknown node voltages we are left with? We are left with 2 unknown voltages. So naturally we require 2 equations. Once we solve for these 2 simultaneous equations, we can obtain the value of VB and VC. So let us write down the equations of VB and VC using the same approach that we took for the prior 2 questions. So at VB, I have to write down the KCl equations. There are 3 branches. So what was our assumption? What will be our direction of current? Always in the outward direction. Outward, outward and outward. So writing the equation for the left branch, it can be written as VB minus VA upon 20. Coming to the middle branch. Now the middle branch comprises of a current source. Is the direction of the current source in the outward direction? No. It is in the opposite direction of that of our assumption taken. So it will be minus 0.6. Now coming to the last branch, that is connecting VB and VC, I can write VB minus VC upon 20. 3 branches, equations can be written for all the 3 branches. That is equal to 0. Always remember one thing, whether you are writing KCl equations or you are writing KVL equations. If you are writing KCl equations, all your equations terms should be in the form of current. Look over here. This is V upon R. So it is a current. This is a current value. This is again V upon R. You cannot use any other form to write a KCl equation. Similarly, when you are writing KVL, you can only write the equation in terms of voltages. Either you can write in terms of source voltages or you have to write in the terms of I into R. You cannot use any other form, and this is very, very important. Whenever you are writing the equation, please check if this is KCl, then every term in the KCl should come out to be a current in the form of I only or in the form of V upon R. So this is the first equation already written for VB. Now moving on to VC. We have already written over here that there are 4 branches connected to VC, so we will have 4 terms. So I'll begin with this one. So what can I write for that branch? I can write VC minus VA upon 50. Because what will be the direction of current? It is in the outward direction. So it will start from VC and it will try to reach VA. VC minus VA upon 50. Now coming to the second branch. The branch is connecting VB and VC. So what can I write? Plus VC minus VB upon 20. Yes, one more thing. Please remember, the node for which you are writing the equation is the parent node or the node at the higher potential. All other nodes will be at a lower potential because you are writing the equation for that particular node. Second branch will be this, the diagonal branch. So what can I write? There is already a voltage source present. So what is the last sign that is being encountered for this voltage source? It is minus. So it will be VC minus 12 minus 0 upon 50. For the final branch, there is only one resistor present in between the ground potential and that node. So you will be writing it as VC minus 0 upon 100. 4 branches, 4 terms already written. So this is equal to 0 and this is your second equation. We had 2 unknowns and we have already obtained 2 equations. Let us now simplify these equations and obtain the values for VB and VC. Upon simplification for the VB equation, one can obtain, and upon simplification of the VC equation, one obtains, it is already known to us that the value of VA is 60 volts. So I have substituted the value of VA in both these equations and I have obtained these 2 simplified equations. As usual, please remember, whenever you simplify these equations and write them in the term of the simultaneous equations, maintain the order. VB first, followed by VC. In case one of the values are missing, leave that space blank, or you can write that 0 times that particular value which is missing. Because eventually you have to solve these type of equations in your calculators. And the calculator takes the values in a matrix form. So your matrix should not be distorted. So upon solving these two simultaneous equations and using the calculator, using a scientific calculator of course, the value of VB will come out to be 57.6 volts and the value of VC will come out to be 43.2 volts. So here we come to the end of our nodal analysis class. This is how one has to solve the circuits for obtaining the nodal voltages using the nodal analysis concept. I hope you guys have understood how to work out these problems. Practice sets will be provided in the description box. You can try out those questions. In case of any queries, you can post your queries in the comment section, and upon solving the practice sets, please post your answers also in the comment section. Or if you are unable to solve any questions in the practice set, you can please ask for that and I'll try to solve those questions in the upcoming videos. Thank you.